Hello there, this is James. We're going to do a session here all about cardiac volumes, and my first job is to draw what I absolutely guarantee is going to be the most magnificent heart-shaped object you have ever seen. And there you go. That is it. I'm so embarrassed about that, but I'm actually going to do it again. So look, I just want to draw here an object which looks loosely like a heart or some kind of representation of the heart. And the other thing I'm going to do is I'm going to separate it into sort of its four chambers, because we know the heart is separated into the upper chambers, the atria, and we know it's separated into the lower chambers, the ventricles. We've studied that recently, and that's good news. We like that because we know that already. Now, the other thing I want you to bear in mind is that, of course, when these ventricles start to go through a process of systole, we already know, of course, systole is contraction, and ejecting or emptying. When systole occurs, the ventricles start to eject blood. So what we're going to do is we're going to imagine that from the left ventricle, here's the left ventricle here, we have blood coming upwards and outwards, and as we know, it leaves the heart via the aorta. You should be screaming at your screen, I hope. And let's just imagine a scenario where the aorta comes round like this. To be honest, it goes behind the heart. But what we're going to do is we're going to imagine a scenario where we collect this blood in a big beaker. Now, don't try this at home. You will make a mess. But what we want to do is we want to imagine how much blood, or what would be the amount of blood that would be ejected each and every phase of systole. Okay, so what would be the amount of blood ejected each systole? And when we actually think about that quantity, we can give that quantity a name. And the name I want you to start using is what we would refer to as stroke. And that's just, a hot beat. Stroke volume. So each time the heart goes through systole or contracts, it's going to deposit some quantity of blood in our experiment into this beaker, and whatever that quantity is going to be our stroke volume. Now, what I'm going to suggest to you is that for the average person, that is going to be in the region of 70 milliliters of blood. 70 milliliters of blood. So, not a great deal, relatively small amount each time the heart contracts. We're going to get roughly 70 milliliters. So what then happens if we take our stroke volume, which is the amount of blood that leaves the, in this case, left ventricle each time it contracts, what if we multiply that by the number of times the heart actually pumps per minute? So we call that our heart rate. Okay, so if we get stroke volume times heart rate, that gives us a reading that we refer to as, and I wonder how many of you know this already, as our cardiac output. Our cardiac output. Now, I hope straight away that sort of means something to you. The output of the cardiac. So output's like how much leaves or comes out. Cardiac is all about the heart. So it's the output of the heart per minute. Now, we can actually therefore go about sort of like calculating this. We can say, right, well, we know stroke volume is roughly 70 milliliters per each time. We know that heart rate at rest, is something in the region of 70 beats per minute. And as a result, we can figure out that our cardiac output would be 4,900 milliliters, or what we'd probably write is 4.9 liters. Okay, so 5 liters of blood leaving the heart per minute, and that's what we describe as our cardiac output. Now, the only other point really I want to make is to say that, well, of course, when we start exercising, these values go up. So first of all, our stroke volume increases. Secondly, we know, of course, that our heart rate goes up, and therefore, as a result, our cardiac output goes up significantly because the two components of it go up themselves in turn. So that is to say, and it should make sort of intuitive sense to you, that when we exercise, we are able to move a much greater cardiac output because both our stroke volume increases and also our heart rate increases, and therefore as a result of that we get a much greater cardiac output. And of course, if you think about what that cardiac output does, it carries oxygen, it brings CO2 back to the lung, for example, for removal. Therefore that becomes very resourceful and useful for the athlete as they are performing, because therefore we can exchange more gases, we can produce more energy, and we can continue to work aerobically. Thanks for listening. Have a good day.